Hello my dear students. So I am going to continue with the extra questions related to rate of reaction. In the previous chapter also I discussed some questions with you all. You are familiar with rate of reactions. What is it? The amount of change that occurred in a unit time related to a reaction. And this is given by the amount of reactants used up in a unit time or the amount of products formed in a unit time. And you all know there are four factors: surface area of reactants, concentration of reactants or pressure of gaseous reactants, the temperature at which the reaction takes place, and the catalyst. These are the factors that can affect the rate of reaction. Why? Because for a reaction to occur, there should be collision between particles of the reactants. So, if these factors, or actually these factors can change the rate of collision. So, when they increase the rate of collision, the rate of reaction increases. If they decrease the rate of collision, the rate of reaction decreases. So, that is how they affect the rate of reaction. So, with that introduction, we will discuss the questions. So, I am sure, like you all did before, you will answer the questions by yourself first and then you will compare your answer with my discussion. Extra question 11. What is the name given to the substance that reduces the rate of a reaction? What is that? We say the factors that affect rate of reaction. Under that we discuss catalyst. Catalyst always increase the rate of reaction. But the inhibitors decrease the rate of reaction. You all know an example. When you put sulfuric acid to hydrogen peroxide, normally hydrogen peroxide dissociates to form water and oxygen. So that rate is reduced when you add sulfuric acid. So sulfuric acid is an inhibitor. So here, what is the name given to the substance that reduces the rate of reaction? It is the inhibitor. Inhibitors. Second one, write an example for the substance that you mentioned above. So for that, we can write the example: sulfuric acid. Sulfuric acid inhibits the dissociation of hydrogen peroxide. Sulfuric acid inhibits the dissociation of hydrogen peroxide. Or you can say the dissociation of hydrogen peroxide can be inhibited by sulfuric acid. Or you can say sulfuric acid reduces the rate of dissociation of hydrogen peroxide. Anyway, you can mention that. So, as an example for inhibitor, you can consider sulfuric acid. Is that okay, students? So, then we'll move on to the next question. Extra question 12. What are the biological catalysts? What are the biological catalysts? Those are the enzymes. Enzymes are biological catalysts. So, that is what you need to write there. Enzymes. Enzymes are biological catalysts. Why do we call them biological catalysts? Enzymes are made up of protein. They increase the rate of biochemical reactions. You all will be learning more, but we have already discussed amylase, salivary amylase. That increases the hydrolysis of starch to maltose. The rate of hydrolysis of starch to maltose is increased by the enzyme amylase. So, like that, there are many enzymes. These enzymes are biological catalysts. So, they increase the rate of reaction of biochemical reactions or biological reactions that take place inside the body of living organisms. Then the second one. What is the function of enzymes in the exhaust system of motor vehicles? So, this is another question that you have to answer. what is the function of enzymes in the exhaust system of motor vehicles. If you all can remember, students, this is given in your textbook under extra knowledge. So you are familiar with the exhaust system of motor vehicles. They have the catalytic converter in them. Now you all can remember when we say exhaust, when fuel undergoes combustion. Normally carbon dioxide is evolved. But in addition to that, there are some pollutant gases or toxic gases. For example, carbon monoxide and nitric oxide. Carbon monoxide is CO, nitric oxide is NO. Now these two gases are pollutant gases. If they evolve into the environment, that can pollute the environment. So because of that, what they do is they have a catalytic converter connected to the exhaust system, and these catalysts convert carbon monoxide into carbon dioxide and nitric oxide into nitrogen gas. So those two gases, carbon dioxide and nitrogen, they are non-pollutant gases. So that is the function of enzymes in the exhaust system of motor vehicles. So you need to explain that. With exhaust gases like carbon monoxide, that is CO, and nitric oxide, NO, are released. These are pollutant gases. A catalytic converter is attached to the exhaust system. The enzymes in the catalytic converter converts carbon monoxide and nitric oxide into carbon dioxide and nitrogen gases. These are non-pollutant gases. So, or you can say, basically, the enzymes present in the catalytic converter converts pollutant gases carbon monoxide and nitric oxide into non-pollutant gases, CO2 and N2 gas. So that is the explanation you can give. So here you can see what is the function of enzymes in the exhaust system of motor vehicles. with exhaust gases like carbon monoxide and nitric oxide are released. These are pollutant gases. A catalytic converter is attached to the exhaust system. The enzymes in the catalytic converter converts carbon monoxide and nitric oxide into carbon dioxide and nitrogen gases. These are non-pollutant gases. Or you can say, basically the enzymes present in the catalytic converter converts pollutant gases, that is carbon monoxide and nitric oxide, into non-pollutant gases, that are carbon dioxide and nitrogen gas. So that is what you need to explain there. Functions of catalyst or enzymes. There are enzymes in our body, living organisms, and also there are enzymes which do other functions. Even in some of the washing powders, there are enzymes that are used to remove stains. So that is also another application of enzymes. So these are some things that you all need to know, students. So with that, we will move on to the next question. Extra question 30. Hydrogen peroxide undergoes dissociation as shown below. So there is hydrogen peroxide inside a test tube, and you can see the test tube is connected to a syringe, a piston and a syringe. Here you can see a syringe, and there is oxygen gas being collected. So there they can measure the volume of oxygen gas that is collected in a unit time, or they can fix the volume of oxygen gas and measure the time taken to collect that particular gas. So there they can compare the rate of reactions. So then, first one, what type of a reaction is the dissociation of hydrogen peroxide? It is a decomposition reaction. So it is a chemical decomposition reaction. You can remember, students, hydrogen peroxide is H2O2 that decomposes to form H2O and oxygen. So it is a chemical decomposition reaction. What does a catalyst do to the rate of a reaction? What does a catalyst do? It increases the rate of a reaction. So catalyst increase the rate of a reaction. Catalyst increase the rate of a reaction. That is what a catalyst does to a reaction. So with that, we'll move on to the next part. Third one, accurately weighed 0.2 grams of manganese dioxide was added to the setup shown below. What will be the observation? What will happen when you add manganese dioxide? That is a catalyst that increases the rate of dissociation of hydrogen peroxide. So what will be the observation? The rate of fizzing will become faster. You can say rate of fizzing will increase, or you can say gas bubbles evolve faster. Gas bubbles are liberated faster, gas bubbles evolve faster, anything is fine as long as you say that the rate of reaction is higher. Then the fourth one, the manganese dioxide was filtered and weighed after the completion of the reaction. Will there be a change in the mass of magnesium dioxide? Will there be a change? No. Why? Because a property of catalyst is that it is not chemically consumed during the reaction. So therefore, the mass will not change. The answer is no. You all should know the reason as well. Then the next one. Write two other properties of a catalyst other than that you observed in part 4 above. What are the other two properties of a catalyst? There are actually three properties. Catalyst is specific to a particular reaction. Now you all remember porous iron is used in the manufacture of ammonia, whereas nickel is used in the manufacture of margarine. Like that, manganese dioxide is specific to the reaction of hydrogen peroxide, dissociation of hydrogen peroxide. So, catalyst is specific to a particular reaction, and also a very small amount is more than enough to catalyze a reaction. So, those are two properties that you can write for a catalyst. Catalyst is specific for a reaction. A small amount is enough to catalyze a reaction. So, those are the properties of a catalyst. So, that is all for this particular question. Write two other properties of a catalyst other than that you observe in part 4 above. In part 4, we saw that they are not chemically consumed. There are two other properties, that it is specific for a reaction and also small amount is enough to catalyze a reaction. So, you all have to remember all these properties, students. So, with that, we'll move on to the next part, extra question 15. So, here a diagram is given to you. You can see inside a container there is dilute hydrochloric acid, then calcium carbonate chips are there. You can see the evolving of gas bubbles. And on this side, that is setup A. On this side, we have setup B, again dilute hydrochloric acid, but here there is calcium carbonate powder. There also you can see the evolving of gas bubbles. You know the reaction. Calcium carbonate with hydrochloric acid, there is calcium chloride, carbon dioxide and water. Those are the products. So, you can see the evolving of carbon dioxide gas bubbles. Calcium carbonate chips and powder of equal mass were taken into two similar beakers as shown above. So, those are the beakers. Equal volume of the same dilute hydrochloric acid solution was added to both beakers simultaneously, and they would have observed the rate of fizzing. Compare the rate of fizzing in beakers A and D. So, rate of fizzing A is chips, B is powder. So, B will be greater. When you use powder, what happens? The surface area of reactants increases, therefore the rate of reaction increases. So, that is why the rate of fizzing increases. Is that okay? So, rate of fizzing is high in B compared to A. Then the next one. What factor affecting the rate of reaction was studied in the above activity? What is the factor? Surface area of reactant. Surface area of reactant. Here what is the reactant? It is calcium carbonate. So, we use calcium carbonate chips and calcium carbonate powder. So, those are the answers to these questions. We will move on to the next questions. Same diagram. Third one. Explain how the factor you mentioned above increases the rate of reaction. So, how does this factor increase the rate of reaction? When you break or when you crush the piece of or chips of calcium carbonate into calcium carbonate powder, the surface area of reactant increases, then the number of collisions per unit time increases. Because of that, the rate of reaction increases. So, we can say surface area of reactant is high in powder compared to chips. When surface area increases, the number of collisions per unit time increases. Therefore, the rate of reaction increases. So if we look at the question, explain how the factor you mentioned above increases the rate of reaction. Surface area of reactant is high in powder compared to chips. When surface area increases, the number of collisions per unit time increases. Therefore, the rate of reaction increases. So that is how this particular factor, surface area, increases the rate of reaction. So I am sure students, you all can understand this explanation. So with that, we will move on to the next question. Extra question 60. Equal amount of strip and pieces of magnesium were separately made to react with 100 centimeter cube of 0.2 moles per decimeter cube HCl. So they have given the volume, they have given the concentration of hydrochloric acid, and they have said equal amount of strip and pieces of magnesium. So the mass is the same, but when they use strip and pieces, the surface area of magnesium changes. So you can understand that. The volume of gas produced by the two reactions was measured and represented on a graph as shown. So what happens there? Magnesium reacts with HCl, forming magnesium chloride and releasing hydrogen gas. So they have collected the hydrogen gas and the volume of hydrogen gas was measured and it had been plotted. If you look at the graph, now on y-axis we have volume of the gas in centimeter cubes, x-axis is time in minutes. And you can see it has been calibrated 0, 0.4, 0.8, 1.2, 1.6, 2, 2.4, 2.8 and 3.2. On this side, the time is given from 1 to 9 minutes. Then you can see there are two graphs. One is x, the other one is y. Now here you can see x, we have drawn graphs like this. You can remember that. Now here you can see for x, the volume of hydrogen collected increases gradually, and when it reaches this point, here you can see when it reaches this point, that is 7 minutes only, it is becoming straight. So thereafter 7, 8, 9, it is the same volume. So that means the reaction completes at this point. That is for x. The same way, if you consider the graph y, you can see it gradually increases. When it comes to this point, it becomes a straight line that is parallel to the x-axis. So that is here. From this, you can see it's here. So after 5 seconds, y. Now this is after 5 minutes. Here x is after 7 minutes. It completes after 7 minutes, whereas y completes after 5 minutes. So what is the fastest reaction? If it takes a longer time to collect a certain volume of gas, that means the reaction is slow. So from this, you can understand it takes a longer time to collect the gas in x, so the rate of reaction is slow. Y occurs faster, so the rate of reaction is faster. So since they use strip and pieces, which is going to be the strip? X will be the strip and y is going to be pieces. So that is how you can interpret the information from a graph. So we have got all these information from this graph. Now let's look at the questions. Out of x and y, what is the graph related to pieces of magnesium? So we have identified y. Why? Because y, after the end of 5 minutes, the amount of gas is collected and thereafter the volume of gas is constant. So that means it has reached completion of the reaction. So therefore y has to be pieces, related to pieces of magnesium, y. Write a reason for your answer in 1 above. So in part 1 above, how did you come to this conclusion? Because the maximum volume of hydrogen gas has been collected in 5 minutes faster. So we can say the volume of gas is collected in 5 minutes. That is a less time period compared to x. So the rate of reaction is faster in y. So that is how we come to that conclusion. The volume of gas is collected in 5 minutes. That is a less time period compared to x. So the rate of reaction is faster in y. That is what we need to explain. You have to give this concept in your own words. I am sure you all can understand these, students. So then we'll move on to the next part of the question. Part 3, the same graph. I have explained this to you all well. What is the rate of reaction of the reaction of X at the end of the second minute? So after 2 minutes, you have to consider that. Now 2 minutes and X. If we draw a line here and here. So if we calculate, now volume of gas that has been collected is 0.8 centimeter cubes and it is 2 minutes. How do you calculate the rate of reaction? Amount of reactants used up divided by time or amount of products formed in a unit time. So here the gas is the product. So that is what you have to calculate here. Rate volume of gas collected divided by time. 0.8 centimeter cubes divided by 2 minutes. That will be 0.4 centimeter cube per minute. You can write minute minus 1 or you can write it as per minute. 0.4 centimeter cube per minute. That is the rate of reaction after 2 seconds. Is that clear to you all? So here, of course, students, the unit is going to be the units given in the graph. Since it has been given in centimeter cubes and minutes, we directly use those units. You don't have to do a unit conversion. Then the fourth one. What is the maximum volume of the gas collected? Maximum volume of the gas collected. Here, this is the maximum volume. At this point only, it becomes a straight line. So, if we extrapolate this line, it comes to somewhere between 2 and 2.4. So, then of course, you all can take it as 2.2 centimeter cubes. What is the maximum volume of the gas collected? I will say 2.2 centimeter cube. If you exactly draw a proper graph and if you measure the length, then of course you can calculate it accordingly here, but you all can see it's almost like the midpoint between 2 and 2.4. So it can be taken as 2.2 centimeter cubes. So this is, students, for you all to get an idea as to how to answer the questions. We are not going into exact calculations. I am giving you all an idea. So then, with that, I will move on to the next question. Extra question 70. 3 set of apparatus arranged for comparing reaction rates with 50 centimeter cube of hydrochloric acid solutions of concentration 1 mole per decimeter cube in each are given below. So there are 3 sets of apparatus. What is the apparatus? You can see there is a water bath. So there is a temperature shown to you all. Then here you can see, students, there is a thistle funnel. Normally you all know thistle funnel is used to add acid or solutions into the reacting container. This is a flat bottom flask is kept inside the water bath, and there is a stopper, there is a glass tube there, and here you can see calcium carbonate chips. So when acid, now here of course it will be HCl acid. When they add HCl into calcium carbonate chips, it will react and carbon dioxide will be evolved. That will be evolved through this glass tube, CO2. So you can get all this information. Here of course they have given 5 grams chips and 30 degrees Celsius. Then on this setup, the second setup, that is Y, you can see the same things. Temperature is the same, water bath, but calcium carbonate powder 5 grams. And setup Z, that is the third one. Same setup, water bath is at 60 degrees Celsius and calcium carbonate powder. So if you take X and Y, chips and powder, temperature is the same HCl solution. So what is the factor there? It is the surface area of calcium carbonate, chips and powder. Then you take Y and Z, 30 degrees and 60 degrees, but both are powder. So there it is the temperature, effect of temperature that they are observing. So 2 factors, X and Y, surface area of reactants, Y and Z, temperature of the reaction. So that is how they have arranged this apparatus. So then, the first question. What factor affecting the rate of the above reaction was studied by, first one, the pair X and Y. So we said it is the surface area of reactant. Surface area of reactant. Y and Z, temperature of the reaction. Temperature of the reaction. Right. So that is the first part of the question. We will move on to the next part of the question. Again, you have the same diagram. We have discussed and understood what happens during the activity. So I'll move on to the question. Second one, what observation will you use to compare the reaction rates in Y and Z? Y and Z, what is the observation? You will see the evolving of gas bubbles. You can observe the rate of fizzing. So that can be used, because here, although they have shown the glass tube, they have not shown the gas being collected. So there you will observe the rate of fizzing. So here we have to say rate of fizzing. Rate of fizzing, F-I-S-S-I-N-G or F-I-Z-Z-I-N-G, rate of fizzing. In addition to the factors stated in 1A and B above, write another factor that affects the rate of this reaction. So in A and B, if you can remember, A was X and Y, it was the surface area of reactants. B, Y and Z, that was the temperature. So surface area, temperature. What is another factor? Here, of course, for this reaction, there is no catalyst, but by changing the concentration of hydrochloric acid, you can change the rate of reaction. So that is the next factor. In addition to the factors stated in 1A and B above, write another factor that affects the rate of this reaction, that is concentration. Concentration of hydrochloric acid. Concentration of HCl, hydrochloric acid. Then the next one. If the setup Z along with Y is used to investigate the effect of the factor stated in 3 above, write 2 changes that should be made. What are the 2 changes you need to make in order to have concentrations? Now here in none of these the concentration is mentioned. So then what do? We need to take equal volume, final volume has to be the same, but you need to add water and hydrochloric acid in different proportions. So those are the changes that you need to do. Here also we will be taking the same volume but the same acid. So when you change, you will have to change the volume of water and change the volume of hydrochloric acid. So those are the 2 changes. The volume of hydrochloric acid and water need to be changed while maintaining the total volume constant. So like as an example, if I say that is X, Y and Z, we will say P you can have 5 milliliters of HCl. So we can have 5 milliliters of hydrochloric acid and 15 milliliters of water. Then you will have another setup where you can use 10 milliliters of hydrochloric acid and 10 milliliters of water. So when we say 2 changes, you can see 5 milliliters, 10 milliliters. Change the volume of HCl, 15 milliliters and 10 milliliters, changing the volume of water. So 2 changes. But the final volume, 5 and 15, 20, 10 and 10, 20. We maintain the total volume constant. Like this, you can even have more setup. Like you can have PQR, this can be 15 milliliters and 5 milliliters of water. So you can have 3 different concentrations or you can just stick to 2 different concentrations. But what should be calcium carbonate? We have to stick to either calcium carbonate powder or calcium carbonate chips. It's easier to go for calcium carbonate powder. And also you need to maintain the temperature constant. Temperature has to be maintained and the surface area of reactants have to be the same. So you all know that, students. When we are trying to demonstrate the effect of one factor, the other factors have to be constant. So that is how we do the activity. If the setup Z along with Y is used to investigate the effect of the factor stated in 3 above, that is concentration of HCl, write 2 changes that should be made. So these are the 2 changes. Change the volume of HCl and change the volume of water, but maintain the total volume constant. Is that clear to you all, students? So with that, we will move on to the next slide. The questions are continuing the same diagram, so you all know what happened there during the activity. The fifth question. A group of students wanted to calculate the rate of reaction in X and Y by measuring the time taken to collect a given volume of the gas evolved. So they want to measure the time taken to collect a given volume of the gas evolved. Under that, A part, what is the gas evolved in the above activity? So we have already discussed that calcium carbonate when reacted with hydrochloric acid, calcium chloride, water and carbon dioxide. Carbon dioxide is the gas. So you can write it as CO2 or you can write it in words carbon dioxide. Then B, what method can you use to collect the above gas? How can you collect the gas? Either to this glass tube you can attach a syringe and with that it can be collected. If it is the syringe, the piston is compressed completely, then there is no air. After that you connect it to the glass tube. So while the gas is being released, the piston will move and the volume of gas can be collected. But normally in the laboratory, you all know if to collect carbon dioxide gas, you can use downward displacement of water or else you can use upward displacement of air because carbon dioxide is more denser than air. Either method can be used. But here, what method can you use to collect the above gas? Here we can say by attaching a syringe with a piston. So here by attaching a syringe with a piston. Then the next question. Illustrate using a diagram how setup X, that is the first setup, should be modified by the group of students to collect the gas. So there we need to show the setup X. We have the water bath, then the flat bottom flask. You have the water bath. Then we have the flat bottom flask. You need to have the thistle funnel and the glass tube there. This is the thistle funnel. Then we need to have calcium carbonate chips. We have the water bath. Then here, of course, we need to connect the syringe with a piston. So normally before attaching, the syringe piston has to be pushed up to this point. So there is nothing inside the syringe. Once you attach it, when the reaction is taking place, the gas will evolve and it will be directed through this glass tube and into the syringe. So the piston will be pushed back and the gas will be collected. So that is what we do to collect the gas. So if you look at it, here calcium carbonate chips 5 grams and water bath 30 degrees Celsius. So 30 degrees Celsius, calcium carbonate chips 5.0 grams. That is the difference. So this is the main part that you have to show. that you are collecting carbon dioxide gas. Here we can say CO2 is collected. Within brackets I can say when connecting the syringe to the glass tube, there should be no air inside it. So then the setup is complete. Is that clear to you all students? So if we show that, or else you have to use a delivery tube and you have to draw the setup where you can collect the gas using downward displacement of water. That is also possible. I will show only this part for you all because already I have drawn the setup apparatus. So if you are collecting it using downward displacement of water, then you will need to have a trough, then you need to have the beehive shelf, you need to have the gas jar, and then from the glass tube you need to have the rubber tube. There is water. Trough with water. Beehive shelf. Gas jar filled with water and delivery tube, that is the glass tube. So here you will have the rest of the setup. I am not going to redraw because this is another way you can collect the gas. This is by downward displacement of water. So if you want, you can also show for the upward displacement of air. But there is a problem when we use upward displacement of air, you can't see the difference between air and carbon dioxide. So then of course you don't know the volume of carbon dioxide collected. So that method is not suitable here. You can either use the first method that I have shown there, where you use a syringe, there you can fix the volume. The same way, here also you can fix the volume. You can put a rubber band up to this point. So let's say you put a rubber band for volume mark. Then you can easily fix the volume. You can easily collect the gas up to there and you can measure the time taken. So this method or the previous method, whatever is easy and needed for the particular activity. You can draw just one method, that is more than enough. So the first method or the second method. So I am sure students, I am sure you all can remember all these processes, the activity we did in the lab, and you were able to draw the setup correctly. So with that students, I will move on to the next slide. Extra question 18. Concentration of reactants is a factor that affects the rate of reaction. Define rate of reaction. A very simple question. We started the lesson with that. What is it? The amount of change occurred in a unit time. Rate of reaction. Reaction is the amount of change that occurred in a unit time. So that is the rate of reaction. Rate of reaction is the amount of change that occurred in a unit time. So that is how you define rate of reaction. If you are to calculate rate of reaction, you can say the amount of reactants used up in a unit time or amount of products formed in a unit time. Or this also can be defined in that manner. The amount of reactants used up, or you can say or consumed in a unit time, or it can be the amount of products formed in a unit time. So these two together is given by this definition. When we say rate of reaction is the amount of change, that is the amount of reactants used up or the amount of products formed. So the combination of these two is this particular definition. That's why we use it usually. The rate of reaction is the amount of change that occurred in a unit time, or you can say the amount of reactants used up or consumed in a unit time, the amount of products formed in a unit time. So that is also rate of reaction. This is how we calculate the rate of reaction. So I am sure students, you were able to answer this correctly. With that, I'll move on to the next slide. The following materials are provided to you. 3 pieces of clean magnesium strips of equal surface area, 3 test tubes, dilute hydrochloric acid and water. So there is magnesium and HCl. Strips are of equal surface area, but there is water. So that means water and hydrochloric acid, different volumes. That means there will be different concentrations of hydrochloric acid. Design an activity to find out how concentration affects the rate of reaction using the materials provided. Draw a diagram to illustrate the activity. So there are 3 test tubes. Then 3 test tubes. You will have the equal volume. Then you can show magnesium. That is also magnesium. Then we will label it as A, B, C. In A, you can have 5 centimeter cube HCl and 15 centimeter cube water. Then here I will have 10 centimeter cube HCl and 10 centimeter cube water. This one 15 centimeter cube HCl and 5 centimeter cube water. So the total volume 5 and 15, 20 centimeter cube. Here 10 and 10, 20, 15 and 5, 20. In A, 5 centimeter cube of HCl, B, 10 centimeter cubes of HCl and C, 15 centimeter cubes of HCl. So you can see the concentration increasing from A to C. So I have drawn the activity there. You all also can do it this way. Then the next question. How will you compare the rate of reaction in the above? Magnesium and hydrochloric acid, hydrogen gas will be evolved. The rate of liberation of hydrogen gas. By the rate of liberation of hydrogen gas. You can even say rate of fizzing of hydrogen gas. Anything is fine. Is that okay, students? So then we'll move on to the next one. Third one, write the expected observation. What will be the expected observation? Rate of fizzing. A will be less, B will be more, and C will be the highest. Rate of fizzing A, B, C. That will be the order. That is the expected observation. Then here you can say, explain the above observation based on how a chemical reaction occurs. So when a chemical reaction occurs, what happens? The reactant particles have to collide with each other. So when the concentration is high, there are more reactant particles. Because of that, there are more number of collisions in a unit time. Therefore, the rate of reaction increases. That is what you have to write here. So you can say, when the concentration increases, the number of collisions between reactants in a unit time increases. Therefore, the rate of reaction increases. So that is what happens there. When the concentration increases, the number of collisions between reactants in a unit time increases, and therefore the rate of reaction increases. So that is the answer to this question. With that, students, I'll move on to the next slide. So extra question 19, given below is a sketch of a setup used to test factors that affect rate of reaction. So here you can see they have used a common water bath. So the temperature will be the same. And here you can see HCl 10 milliliters, pieces of calcium carbonate, that is 5 milligrams. But on this side, same amount of HCl 10 milliliters, there is cold water and there is calcium carbonate powder, but the same mass. So here you can see temperature is the same, cold water, volume of HCl is 10 centimeter cube and it has to be the same solution. So concentration is the same. No catalyst, only difference is pieces of calcium carbonate and powder of calcium carbonate. So it is the surface area of reactants that is being tested here. First question, name the factors that affect rate of reaction. Factors that affect rate of reaction, you all know that surface area of reactants, then temperature at which the reaction occurs, and then concentration of reactants, and pressure for gaseous reactants, pressure of gaseous reactants and also catalyst. So, surface area of reactants, temperature at which the reaction occurs, concentration or pressure of gaseous reactants and catalyst. Those are the factors that affect the rate of reaction. I am sure by now you know them by heart very well. Then we'll move on to the next part. Same diagram is given. Which factor is tested by using the above setup? So like I said, concentration is the same, temperature is the same, no catalyst. So it is the surface area. Surface area of reactant. That is calcium carbonate. That is what is being tested. Then the next one. Name two factors that should be kept constant while doing the above experiment. What are the two factors? Although there are three more factors, you can't write catalyst because you know there is no catalyst for this particular reaction. So you have to say temperature and concentration of HCl. Temperature and concentration of hydrochloric acid. So those are the two factors that need to be kept constant. I am sure you all can understand that. With that, students, we'll move on to the next slide. Extra question 20. So this is the last question of this chapter. The following activity was carried out by a group of grade 10 students to observe the effects of different factors on the rate of reaction. Answer the questions based on this activity. So look at the activity ABC, calcium carbonate chips, calcium carbonate powder. So surface area, that is different. Then you have dilute sulfuric acid in all three. Volume is the same acid, so concentration is not different. Then temperature, 30 degrees, 60 degrees. So effect of two factors, surface area of reactants as well as temperature. So both are tested here. First one, identify the pair of setup suitable to find out the effect of the surface area of reactants and the temperature on the rate of reactions respectively. So they have mentioned the factors, but they want you to identify the pair of setup. So if it is surface area, the temperature should be same. So A and B 30 degrees. Calcium carbonate chips and calcium carbonate powder. So it should be A and B. Then for temperature, then of course surface area should be the same. This is calcium carbonate chips. Both these are calcium carbonate powder. Temperature 30 degrees and 60 degrees. So they should be B and C. B and C. So that is how you identify the pair of test tubes that are responsible or that can be used to observe the effect of these two factors. Is that clear, student? So then we'll move on to the next slide. Again the same diagram. Second question. Write another factor that affects the rate of reaction that is not mentioned above. So previously we mentioned temperature, concentration and surface area. But I did not mention catalyst there. So this is not related to the above reaction. They have just asked rate of reaction. So it is catalyst. Catalyst. Then write a factor that affects only the rate of reaction of gaseous reactants. What is that? Pressure of the gaseous reactants. So pressure of the gaseous reactants. So that is the factor that affects only the rate of reaction of gaseous reactant. Is that okay, students? So then I'll move on to the next slide. Fourth one. Again, here you all can see it is the same activity. We have discussed that. Explain how the above factors increase the rate of reaction. So you need to explain how the factors affect the rate of reaction. So explain. Now if we say surface area when increased, the number of collisions in a unit time increases. Therefore, rate of reaction increases. So that is one factor. Then we can say temperature. When temperature increases, the kinetic energy of reactants increases. Then the number of collisions per unit time increases and the rate increases. The next one, we have written surface area, then I have explained temperature, then concentration. So when concentration increases, what happens? Concentration increases, the number of reactant particles increases, again therefore the number of collisions increases and the rate of reaction increases. Concentration when increased, the number of collisions in a unit time increases, thus rate increases. Catalyst, of course, increases the rate of reaction. There, of course, we don't explain it using this. So here, if we look at all the factors, surface area when increased, the number of collisions in a unit time increases, therefore rate of reaction increases. Then temperature. When temperature increases, the kinetic energy of reactants increases. Then the number of collisions per unit time increases and the rate increases. And finally, concentration. When increased, the number of collisions in a unit time, actually number of collisions in a unit volume also increases. Therefore, the rate increases. So that is how you are supposed to explain how these factors affect rate of reaction. Catalyst, of course, is a substance that increases the rate of reaction. So with that, students, I have come to the end of this chapter and for that matter, end of this lesson. So I am sure now you have a very good understanding about the rate of reaction, how to calculate it, and the factors that affect the rate of reaction and all the activities related to that.